Alright, so this is going to be my fifth example on improper integrals. So here we have improper integrals with infinite integration limits. So if I have the integral a to infinity of f of x dx, then I can write that as the limit as b goes to infinity of the integral a to b f of x dx. So what I'm doing is I'm taking this infinity, I'm replacing it with b, and then I'm taking the limit as b goes to infinity. Okay, and then similar here, I'll replace the negative infinity with b and take the limit as b goes to negative infinity. And then if I have my limits are negative infinity to infinity, then what I'm going to do is I'm going to split this up from negative infinity to c plus c to infinity, and c is any real number. And typically what we do for the c here is we'll usually let it be 0. It usually makes it easier to evaluate the integral. Alright, so let's take a look at an example. Alright, so here we have the limit, we have the integral negative infinity to infinity of e to the x over 1 plus e to the 2x dx. Alright, so first thing we want to do is let's just rewrite this from negative infinity, and we'll pick a number between negative infinity and infinity, be any real number, and I'm going to choose 0. That's e to the x over 1 plus e to the 2x dx plus 0 to infinity of e to the x over 1 plus e to the 2x dx. Alright, so now let's rewrite this. That's going to be the limit as b goes to, and then for this one, okay, for this one, b is going to go to negative infinity, and so that's b to 0, e to the x over 1 plus e to the 2x dx plus, and then for this one, I'm going to do the limit as b goes to infinity, and that's going to be 0 to b, e to the x over 1 plus e to the 2x dx. Alright, so now we need to integrate each one of these. Alright, well, if you look at this term here, okay, and it's going to be the same in both. Okay, I'm going to show you on this one. This e to the 2x can be written as e to the x squared. Okay, so that would be 1 plus e to the x squared. And then notice the derivative of this term is in my numerator. So do you remember what that would be? Well, remember that 1 over 1 plus x squared, the integral of that, is equal to arctan x plus c. Okay, so the antiderivative of this, that would be the limit as b goes to negative infinity, and this would be arctan e to the x, and that's going from b to 0, plus, and then this one would be the same thing, plus the limit as b goes to infinity of arctan e to the x, and in this case it would be from 0 to b. Okay. Alright, so now we just evaluate. So this is going to be the limit as b goes to negative infinity of arctan e to the 0 minus arctan of b plus the limit as b goes to infinity, and now this one, that would be arctan of b minus, I'm sorry, and I messed up here too, didn't I? This wouldn't, we have to plug the b in, so that would be e to the b. And then here we have arctan e to the b minus arctan e to the 0. Alright, so now I think we've got that straightened away. Alright, so we're going to take the 0, plug it in. That gives us arctan e to the 0 minus, and then we plug the b in, arctan e to the b. And now for this one, we plug the b in, so arctan e to the b minus, and then we plug the 0 in, arctan e to the 0. Alright, so now I think I'm squared away now. Alright, so now what we have here is, well, we take the limit of each of these. Well, this e to the 0 is just 1. So what's the arctan of 1? Well, that's pi over 4 minus, and now we do this one. Okay, now do you remember what this is? Well, as e to the b, that goes as b goes to negative infinity. Okay, so if we come down here, that's like e to the b is to the negative infinity, so these are negative numbers. So if I write it as 1 over e, and see how it was negative up here? Well, if I bring it down here, that's the exponent becomes positive. So that means this term down here is getting really big, so the whole fraction is going to 0. So I would be taking the arctan of 0, and the arctan of 0 is 0. Okay. Alright, now let's look at this one. Well, as b gets bigger, e to the b is getting bigger, because see, b is going to infinity. Well, what's the limit of arctan as it's going to infinity? Well, let me just sketch this real quick. Remember what the graph of arctangent looks like? You have what, pi over 2 here, and negative pi over 2 here, and then the graph looks like this. Okay, well, you can see as we're going to infinity, arctangent is approaching this line pi over 2. So this term is approaching pi over 2. Alright, let me get this out of the way. Alright, so that's going to be plus pi over 2 minus, and then once again, this term here, that's 1, and the arctan of 1 is pi over 2, and so we'll be, I'm sorry, not pi over 2, pi over 4. The arctan of 1 is pi over 4, and so this will leave us with pi over 2. Alright, so that's the end of this video. Sorry about the few mess ups, but we got everything corrected. I hope the video helped. If you like the video, you can watch my other ones and you can subscribe. Alright, thanks.